Hi everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the polymers and its applications. So in the previous session we have discussed about the ceramics. So these ceramics generally they have been in between the metal and non-metallic. So wherever the materials which have been available in between the metallic and non-metallic materials, those types of materials are called the ceramics. Now these polymers are completely different. What is happening in the polymers means it is a combination of different elements. So different elements, if you combine together, it will refers to as a polymer. So depending upon the properties or depending upon the applications, we are trying to incorporate different types of other elements to form a single element in order to get a polymer. So a polymer is a large molecule or a macromolecule which is essentially is a combination of many substitutes. So it is a combination of many subunits. So that refers to a polymer. But in case of ceramics, what we have discussed in the previous session, these ceramics is a single unit. But coming to the polymers, it is a combination of many subunits. Okay, so where this term of polymer is coming from is you have a Greek term called many parts. So in the name itself, you have many parts. So a single element is different with the many parts. So a combination of many parts includes different combinations. So that's why it is referred to as a many parts, and it is having many subunits. So that type of material or that type of element is called as a polymer. So the polymer can be found in general around us. So different types of materials what we are finding out in generally day-to-day life. These are all combination of different elements. If you consider any, suppose if you consider the mobile phone, so it is having different types of material. It is not a single material. So like that, if you consider any pen, so it is also a combination of different elements. So like that, in day-to-day life, we have different types of materials what we are using. It is having different subunits. So these types of elements or these types of materials are called as a polymers. That's why it is having many parts. So any material which is having a combination of different materials, and that type of material refers to the polymers. Now from the standard of our DNA, which is a naturally occurring bipolymer of polypropylene, which is used throughout the world as a plastic. Now internal body, okay, what we are having, so this DNA is also having n number of parts. It is not a combination of, it is not a single part, it is a combination of different parts. So this is the best example to define a polymer. Our body consisting of different subunits. It is not single unit. So that is one of the examples of a polymer. And also the plastic, whatever the plastic we are using, this plastic is also not a single unit. It is a combination of different units. So that's why it is called as a polymer. Like this, we have n number of examples to define a polymer. So basic definition of a polymer is nothing but it should consist of many parts. It is not a single part. It should consist of many parts. That refers to a polymer. But when you compare with the ceramics, these ceramics are being available in between the metallic and non-metallic elements, and these ceramics are referred to as single material. So that is the difference between the ceramics as well as the polymers. Now polymers may be found naturally. So where you can find the polymers means in natural, like plants and elements. So that is called as a natural polymers. So wherever the polymers which are available naturally from the plants as well as the animals, so that type of polymer comes under the category of natural polymer. Another thing is what? Man-made things. So whatever the polymers which we are preparing, the man-made materials, these comes under the synthetic type of polymers. So you have different types of polymers depending upon the nature of the availability. Suppose the availability is very naturally we are getting from the plants or from the animals. So that category is the natural polymer. So the name itself you have natural, whichever the polymer which is available naturally. Okay, that type of category comes under the natural polymers. Examples like plants, animals, all those things. And coming to the man-made, so we are trying to prepare some polymer material in order to get some applications. So that type of polymers comes under the category of synthetic polymers. So which we are trying to prepare to the required applications. Now different polymers have a number of unique physical and chemical properties. Is it right? So depending upon the type of application, depending upon the type of availability of the polymers, it is having different physical properties as well as the chemical properties. So depending upon these properties, we are trying to categorize these polymers and we are trying to apply these polymers to the required application. So in that way, you have to identify the polymers which are being synthetic or natural. So depending upon these categories, we are trying to segregate these polymers and we are trying to apply them to the required applications depending upon the physical as well as the chemical properties. So these are different from each other. The synthetic as well as the non-synthetic or the natural available polymers will have different types of properties. It won't have the same properties when you compare with the natural or synthetic. So synthetic will have different chemical properties, different mechanical properties, and here if you go to the natural available fibers, so these will have again different chemical properties and different mechanical properties. So like that, you have to segregate these depending upon the category of the availability of the polymers. Now, first of all, in order to identify which polymer is suitable to the required application means, first we have to know what are the different types of classifications of these polymers. Once if you know the classification, then it is very easy to us to identify, yes, this polymer is suitable for this X product. So how can you define this? Once if you know the basic classifications, and also the physical as well as the chemical properties if you know, then it is very easy for us to identify or pick up the exact polymer to the required application. Now, if you see the classifications of the polymers, polymers cannot be classified under one category. Why? This is very, very important. When you compare with any other material, then it is very easy for us to segregate or categorize any type of material. But coming to the polymers, why it is very difficult means because it is consisting of many parts. So in the first slide, we have seen that the main definition is what? The polymers consisting of many parts. Since it is having many types of parts, it is not that much easy to classify these polymers based upon those things. Why? Because it is having n number of different elements or different parts. That's why it is not categorized in one category. So based upon the availability or based upon the type of nature, we are trying to classify them. Okay, so that's why the polymers cannot be classified under one category because of their complex structure, different behavior and vast application. So main things you have to understand why we cannot categorize these polymers means because it is having complex structure. Why complex means it is having different types of elements inside the body. Suppose if we consider the ceramics, so it is having a single material. That's why the structure is very easy to identify. Coming to the metals, again it is having same single material. So the microstructure study is very easy. But when you come to the polymers, since it is having n number of parts, different types of parts, the microstructure is very complex. That's why we are unable to categorize them. And another thing is what the behavior. That means since it is having different materials, so they will have again in these different materials, each material will have its own property, its own chemical properties, its own mechanical properties, its own physical properties. So because of these different parts which are available, which are incorporated in the polymers, that's why it is very difficult to categorize. The other thing is what? It is having a wide applications. So n number of applications you have when you compare the polymers. That's why because of these three basic things, what are those? The complexity in the structure. The second one is the different behavior of the material. And the third one is it is having very wide or vast applications. So because of these three things, it is not easy to categorize the polymers into one specific characteristics. So that's why what we are trying to find, we are trying to categorize these based upon the different categories. So first of all, first category, how we are trying to identify or how we are trying to classify means classification of polymers based on the source of availability. How the availability, how we are getting these polymers. So that is one of the basic criteria in order to classify them. So first one is what? Based on the availability. How we are trying to get that polymer Okay, that is the first classification. So based upon this, again there is this based upon the availability, again this is subdivided into three categories. So what are those three? There are three types of classifications under this source of availability. The first one is natural, semi-synthetic and synthetic polymers. So these three are there. So first is the natural polymer, second is the semi-synthetic, and third one is synthetic polymers. So these three comes under the source of availability. So first classification is based upon the source of availability, and this source of availability, how it is being available, whether it is naturally available or semi-synthetic or synthetic. So like that you have to differentiate these three classifications under the source of availability. The first one is natural, second is semi-synthetic, and third one is synthetic polymers. Now we'll see what is natural, what is semi-synthetic and synthetic polymers. Now if you see the natural polymers, they occur naturally. So in the name itself you have natural. So what are the polymers which are being available naturally? So those type of polymers comes under this category. So what are those things? Generally we can find these types of natural from the plants and the animals. Okay, so what are the polymers we are getting or we are trying to extract naturally from the plants and the animals, and these types of availability of natural thing of polymers comes under the natural polymers. And what are those examples? Like you have proteins, starch, cellulose and rubber. So these are different types of polymers which are being available naturally from the plants as well as the animals. So what are those? Proteins we are getting from the plants, starch, rubber and cellulose. So these are different types of some of the examples of the natural polymers which are available naturally from the plants and the animals. So these polymers we are not trying to make, we are not preparing them. These are naturally available. So that's why these comes under the category of natural polymers. And to add upon, we also have some biodegradable polymers which are called biopolymers. And some extent we have some other type of degradable polymers, and these types of polymers are called biopolymers. So these are also comes under the natural category. The second one is semi-synthetic. Again, semi-synthetic. So these are nothing but some naturally which are being available. So these are modified something. So that's why they are derived from naturally occurring polymers. So what are the polymers we are trying to get naturally from the first category? These are undergone some further chemical modifications. So that is called as a semi-synthetic. So we are trying to modify whatever the polymers which are available naturally with some chemical processing. Then that type of polymers comes under the semi-synthetic type of things. And what are the examples here? You have cellulose nitrate, cellulose acetate. So what are the cellulose we are getting from the naturally polymers, and these are undergone to some chemical reactions and chemical modifications. Okay, so these are converting from cellulose to cellulose nitrate or cellulose acetate. So these are some of the examples which you are trying to modify from the naturally available polymers. So these are all semi-synthetic type of polymers. The third one is synthetic polymers. So synthetic means these are completely man-made polymers. So we are trying to prepare to the required application our own self. So these are all the polymers which we are trying to prepare by ourselves. That's why these are called as a man-made polymers. So plastic is the most common and widely used synthetic polymer. So the best example of this synthetic polymer is the plastics. So it is having very wide applications in the industries or the daily products, all the things, water bottles, everything. So most of the synthetic polymers are being used in the industries, daily products, the milk products, what we are trying to get, the water bottles. Okay, these are all the man-made polymers. So if you see the examples, you have nylon, polyethylene. So these are some of the examples of the synthetic polymers. So we have three types of categories under the availability nature of the availability of the polymers. So first one is what? Synthetic, second one is semi-synthetic, and third one is natural. So these are all the three different types of polymers which comes under the category of availability of the source. Next is what? Classification of the polymers based upon the structure of the monomer chain. So first category is about the availability. The second category is based upon the structure, how the structure is. So like that we are trying to classify or categorize these polymers. So generally any type of metal can be classified in different forms. But in this case, since it is having very complex structure, wide applications and different types of metals are being there, that's why these polymers are being specifically categorized based upon the availability. So that is the first category we have seen. Second category is based upon the structure of the monomer chain, how the chain inside the material. So that describes the another category. So first one is the linear polymer. So in the name itself we have linear. So if the structure is very linearly in shape, then that type of polymers comes under the linear polymer category. So the structure of polymer containing long and straight chains fall into this category. So wherever the structure, if you see, if it is a linear and in a straight line, then that type of category comes under this linear polymers. So what are the examples of these linear polymers? Means PVC, that is polyvinyl chloride, is largely used in making the pipes, and electrical cables is an example of a linear polymer. So wherever we see the PVC pipes which are used in the household or the industrial applications, so these are all the material which is having a linear structure of its polymer. That means it is having a straight line of chain formation inside the body. So that type of things comes under the linear polymers. So most widely used application is the PVC pipes and also the electrical cables. So these are some of the examples which are being used in the linear polymers. The second category is the branched chain. So again, in the name itself you have to identify so how the shape of these monomer changes vary. So it is a branch type. So wherever the linear chain is there of a polymer, this linear is trying to form into branches. Okay, so what are the linear polymer we have seen in the first category? This linear category, if it's slowly trying to form into some branches, then that type of material comes under this branched chain polymers. And for examples, we can consider as low density polyethylene. So this is one of the example of the branched chain. So whatever the linear polymers are there, if these linear polymers are trying to form into branches, then such type of polymers are categorized under this branched chain polymer. So the best example is the low density polyethylene. Third category is what? Cross-link polymers. Again, this is composed of a bifunctional and trifunctional monomers. So again, it is a different structure from the linear as well as the branch. It is a cross-link. That means it is a bifunctional, different functions it can perform. So that's why it is composed of bifunctional or trifunctional monomers, and they have strong covalent bond in comparison to other linear polymers. So when you compare with the other linear polymers, this crossed link polymers is having a very strong covalent bond, and also it is a bi and trifunctional monomer type of things you have in this cross. So because of these tri and bifunctional things is there in this cross link, that's why it is having very strong bond when you compare with the linear. So in this linear it is having only one type of functionality. But when you compare this cross link, since it is cross linked to each other, that's why it is having a bi and tri-functional things. So because of these bi and tri, what is having the bond between them, the covalent bond between them is very strong when you compare it with any type of linear polymer. And if you see the examples, bakelite and melamine are the best examples which comes under this cross-link category. So like this, the second category we are trying to find based upon the monomer chain structure. So like this, what are the classifications we have? First one is the classification based upon the source of availability. So this source of availability is very, very important. How the availability of the polymer. So that is the first one is the natural, semi-synthetic and synthetic. So like this you have to classify. So what is natural means? Wherever the polymers which are being available naturally from the plants and animals are comes under the category of natural polymers. The semi-synthetic is what? So what are the natural polymers we are getting? We are trying to modify them. We are trying to modify them with some chemical modifications. So that type of polymers comes under the semi-synthetic category. And coming to the synthetic category is completely different. So what we are trying to do? The man-made polymers comes under the synthetic polymers. So the plastic is the most common example to define the synthetic polymers. So this plastic is widely used in the most of the industries, dairy products, okay, which has an example of polyethylene and nylon 6. So these are all some of the man-made polymers which comes under the synthetic polymers. Now coming to the second category is what? Depending upon the monomer, the structure of monomer chain. How the chain of the structure is varying, whether it is a linear or branch or bifunctional. Okay, so depending upon these three, we are trying to classify them. So what is the linear means? If the structure of the polymer containing a long and straight chain of line, and those polymers comes under the linear category. And PVC is one of the best example to define this linear polymer. What are the PVC pipes you are using in the water tanks or household applications? All these comes under the linear polymers. And coming to the branch chain polymers, what is happening here? What are the linear polymer which is being formed, and slowly if it is transforming to some branch type of thing, and those types of polymers comes under this branch chain polymers. So here the low density polyethylene is one of the best example to describe the branch chain polymers. And the third one is what? Crosslink. So in this crosslink, what is happening? Since it is a composed of crosslink, it is having bi and trifunctional monomers. So because of these bi and trifunctional, what is happening? There is a strong covalent bond in between them. So when you compare any bonding with the linear, so this crossed link polymers is having very, very strong covalent bond when you compare with any type of whether it is a linear or branch type of polymers. And bakelite and melamine are the best examples to describe the category of crosslink polymers. And if you see the structure of the polymers, so we are still now we have discussed about what is a polymer, what are the different types of classifications, what are the how does these polymers have been classified. So all these things we have seen. Now coming to the basic structure of the polymer, what is the basic structure of the polymer means? Most of the polymers around us are made up of hydrocarbon backbone. So most of the polymers which are being prepared are of the hydrocarbon backbone. So similar to our backbone or the spinal cord structure, these have been developed. It looked like a structure of a backbone. That's why it is called as a hydrocarbon backbone. The hydrocarbon backbone being a long chain of linked carbon and hydrogen atoms. So why it is called as a hydrocarbon backbone means what are the backbone structure is there inside our body. In the same way, this polymer is also being chained like thing, okay, which is composed of carbon as well as the hydrogen atoms. So possibly due to the trivalent nature of the carbon. So most of the elements or atoms which are being having in this hydrocarbon atoms are based upon the hydrogen as well as the carbon. So these are interlinked to each other. It looks like a backbone structure. That's why it is called hydrocarbon backbone. So most of the polymers having the structure of hydrocarbon backbone type of structure of these polymers. So if you consider the examples of hydrocarbon backbone polymers are polypropylene, polybutylene and polystyrene. So these are three examples, most common examples of these hydrocarbon backbone. Also there are polymers which are instead of carbon have another element in its backbone. So for example, you can replace the carbon by nylon, so which is containing nitrogen atoms in repeated backbone. So what is happening here? Generally, it is composed of hydrogen and carbon in the polymers. So if you want to replace instead of carbon, you can replace with some other type of nylon, and again it is containing nitrogen atoms in the repeated manner. It should be interlinked to each other to form a good linear structure like a backbone structure. So that's why we can replace, since the polymer is composed of many different units. It is not specific to only hydrogen or carbon only. You can replace with hydrogen or carbon with another different atom to increase the strength or to increase the bonding between the elements. So like that, most of the examples which are using in the polymers are the hydrocarbons. So hydrocarbon backbone type of elements or polymers are the polypropylene, polybutane and polystyrene. These are three best examples to describe the hydrocarbon backbone type of structure. And if you want to replace, you can replace with any other type of atom to change the structure as well as the increase the bonding between the elements. And again, type of polymers. So the classification we have seen, and now what are the different types of polymers we have on the basis of the type of backbone chain. So how the backbone chain, the hydrocarbon backbone chain, whether it is inorganic or organic. So based upon these two classifications, again the polymers have been divided. So what are the things? Polymers have been divided into two categories. First one is what? Organic polymers. The first category is organic polymers, in which carbon is a backbone. The second one is inorganic backbone. That means the backbone constituent by elements other than carbon. So that's why in general the polymer is having hydrogen and carbon as the elements, and it will be interbond with each other. So now if we are replacing the backbone with any other element other than the carbon, then that type of category comes under the inorganic. And if the backbone is composed of carbon, then that type of polymer is organic. So two different classifications. If the backbone, what are the backbone we have in the polymers? If it is composed of carbon, then that comes under the organic polymers. In the same fashion, if it is not consisting of the carbon, then that type of polymer is called inorganic. So two different types we have, organic and inorganic, based upon the carbon content. Now on the basis of their synthesis, how it is being prepared. Synthesis is nothing but preparation of the polymer, whether it is a naturally or synthetic. So again you have the different type of the polymers. First one is the natural polymer and the synthetic. So in the natural polymer, what we have discussed, which is available naturally, like cellulose or rubber, okay, all these things. So these are being available naturally. So what are the bond we are seeing? It look like a backbone type of structure, which is composed of hydrogen and carbon atoms. Now in this thing, if you are replacing the carbon with any other element, then that type of category comes under inorganic. In the same backbone, if it is having the carbon content, then that type of polymer is called a organic polymer. And the synthetic is what we are preparing, the man-made polymers. So the best examples are the water bottles, which we are preparing by man. And these are different types of classification, different types of polymers. And coming to the properties, what are the different types of properties we have? The first one is what? Physical properties. So in this physical properties, what is happening? As chain length and the cross-linking increases, the tensile strength of the polymer increases. So whatever the chain we are seeing here, this chain, if you are trying to increase the length of the chain, what is happening? The strength and the tensile strength inside the metal increases. The length of the polymer is very, very important. If you are trying to increase the length, so what is happening? This length, what is trying to do? Chain length, if you are trying to increase, the tensile strength of the polymer is also increasing. So these are directly proportional to each other. The length as well as the tensile strength are directly proportional to each other. If you increase the length of the chain, then the tensile strength is also increasing in these polymers. So that is one of the physical property. Physically, we are trying to increase the length of the chain. So that's why the tensile strength is also being increased parallelly with that. And polymers do not melt. They change state from crystalline to semi-crystalline. So this is one of the different physical properties any other element will have. What is happening here? The polymer do not melt. Though you are heating to its recrystallization temperature, it does not melt. What is trying to do? They will change from crystalline to semi-crystalline state. So if you heat the water bottle, the plastic water bottle, what is happening? It does not melt. What is happening? It is changing from one phase to other phase, the crystalline to semi-crystalline state. So like that, it is one of the different or unique property in case of polymers which is having a physical. So first one is what? The chain length is directly proportional to the tensile strength. So if you increase the chain length, the tensile strength is also increasing. And coming to the other property, what is happening? If you do the melting process also, this does not melt. What is happening? This change from one state to other state, from crystalline to semi-crystalline state. So this is one of the physical property of the polymers. And coming to the chemical properties. So as we discussed in the previous slides, every type of polymer will have its own physical and chemical properties. Why? Because it is having different types of materials, many subunits inside the polymer. That's why each individual subunit, again, it is having its own physical as well as the chemical properties. That's why we have to discuss what are the different types of properties are available inside the polymer. So we have seen the previous thing, how it is being changed. If you want to increase the tensile strength, then we have to increase the chain length of the polymer. And of course, if you do the melting process only, the polymer does not melt and it will change from one state to other state. That is from the crystalline to semi-crystalline state. That is about the physical properties. Now, if you see the chemical properties, what we are having here, compared to conventional molecules with different side molecules, the polymer is enabled with hydrogen bonding and ionic bonding, resulting in better cross-section strength. So, the backbone, what are the backbone we have in the polymer structure? It is composed of the hydrogen and carbon bonding. So, if these bonding having ionic bonding, so what is happening? This will result to the good strength. If you want to have a good strength inside the polymers, so this ionic bonding is very important between the hydrogen as well as the carbon atoms. And dipole bonding side chains enable the polymer for having high flexibility. So here, because of the dipole bonding between the elements inside the polymer structure, so because of this bonding, what is happening? It's having very high flexibility. If you see the empty plastic bottle, you can twist to any other movement. So it's very flexible. It's very highly flexible because of the dipole bonding between these chains of the backbone of the polymers. And polymers with van der Waals forces linking chains are known as to be weak. So what are the polymers with van der Waals force? So you have seen in the previous sessions different types of forces or different types of bonding. So if the polymers with van der Waals forces are there, so then it consists to a weak in nature. So that's why it will be very weak if you have van der Waals forces, but give the polymer a low melting point. So though it is very weak if the polymer consisting with the van der Waals forces, but what is happening? One of the advantage, it will give low melting point. So that is the thing how it is being varied with the chemical in nature. So what are the bonding we have? If it is a ionic bonding, then it will give a better strength. And the second one is what? Depending upon the dipole bonding between the chains, so it is very flexible in nature, highly flexible. And which are the polymers which are being with the van der Waals force, which are being linked with the van der Waals forces, then that type of polymers comes under the very weak in nature, and also it gives a less melting point. So that is about the chemical properties. Now if you see the different uses of polymers, so polypropylene finds usage in broad range of industries such as textiles, packaging, stationery, plastics, aircraft, constructions, rope, toys, and etc. So you have, as we have discussed in the starting, it is a wide application. Since it is having a very wide applications, there is no particular point to classify these polymers. And again, because of the structure, difficulty in the structure, again the categorization is very very difficult. And because of the different types of elements which are being incorporated inside the polymers, that's why it is very difficult to classify them. So that's why, since this polypropylene, since one material, the polypropylene, is having a very very wide usage, like in industries, textiles, stationery, plastics, aircraft constructions, toys, even in toys. So most of the things, this polypropylene is being used. And polystyrene is one of the most common plastic actively used in the packing industry. So most of the packing industry, like the bottles, the containers, trays, disposable glasses, plates, all the things are being done with the polystyrene. And also the TV cabinets and lids are some of the daily used products which are made up of polystyrene. So it is also used as an insulator. So if you see users, you have n number of different types of applications available with the polymers. That's why it is having a wide application. So polypropylene is being used in most of the textiles, even the packing industries, the plastic, aircraft, the constructions, ropes and toys. And polystyrene, so packing industries like bottles, the containers, the trays, disposable glasses, plates, lids, which you are using in the daily products. So all these are wide applications we have with the polymers. And also this polystyrene, in some cases it is used as an insulator also. Another type of important of polyvinyl chloride is the manufacturing of sewage pipes. If you want to do the manufacturing of sewage pipes, these polyvinyl chloride, the PVC pipes, are very very useful in this type of category. And it is also used as an insulator in the electrical cables also. So that's why you have different applications. Small change in the chain, the backbone change, it will lead to the different output. So like that polyvinyl chloride, so the structure, if it is a linear structure, then it is used in the sewage pipes, and also sometimes it is used as an insulator in the electrical cables also. So like that you have different wide applications based upon these polymers which are being available, whether it is naturally synthetic or semi-synthetic. And here polyvinyl chloride is used in the most of the sewage pipes, and also sometimes it is used as an insulator for the electrical cables. And this polyvinyl chloride is used in the clothing and furniture, and has recently become the popular for the construction of doors also, doors and windows as well. And it is used in vinyl flooring also. Like this, you have wide applications in the constructions of doors. Previously, we used to do only with the wooden doors. Now, the PVC doors are also coming because of the hardness or the life tenure of these PVC, and which will not corrodes to the different climatic conditions. So if you compare with the wood, and this PVC is having very very good properties. So that's why these PVC are also not used in the sewage, as well as the insulators for the electrical cables. These are also used in the construction purpose of the doors and windows, and also for the floorings also. So like that, you have wide applications of these polymers based upon the application. Now, if you want to select the particular application, so before selection of the material, you have to know what are the properties of these materials. So once if you know the properties, then it is very easy for us to identify whether this material is suitable for the flooring, or for the wood preparing, door preparation or window preparation, or for the insulation of electrical cables, or for the sewage plants, or different n number of applications. So first of all, you have to know the characteristics, you have to know the properties, whether it is a chemically or mechanically. You have to know all these properties. Then only you can decide the particular material to the required application. Then you have n number of uses with those things. And urea formable layer designs are also used for making adhesives, for combining of the materials, laminated sheets, unbreakable containers. So like this, you have many number of applications. And gate metal is used for making paints, coatings, and decorations. Bakelite is used for electrical switches, kitchen products, toys, jewelry, firearms, insulators, computer disk, and etc. So like that, each element is having different applications. So that's why the first thing we have seen the classifications based upon the availability, how the availability of the polymers are there. So since based upon the availability, whether it is naturally, so natural available polymers cannot be changed to our required application. But once the semi polymers are there, so what we are trying to do, we are trying to enhance the naturally available polymers to with some chemical modifications to the required application. And directly the other thing type of category is what we are completely trying to prepare by our own self, the man-made type of polymers. So these are completely useful for the plastic industries. So like that, you have the bakelite for making electrical switches. So what are the electrical switches we are using? So these electrical switches can be done prepared with the bakelite, and also the kitchen products, toys, insulators, computer discs. All these things are being manufactured with the help of bakelite. So that's why if you want to know the material for any type of applications, first we have to know the properties. The properties comes under again chemical and physical properties, the structure inside the material. Then if you know all these things, then it is very easy for us to select the particular material for the application, any type of application. If you see the commercial uses of the polymers, you have different type of monomer and uses of polymer. If you see the rubber, it is consisting of isopropane. And what are the applications please? Using making tires, elastic materials. So what are the tires we are having? What are the elastic materials we are having? So these comes under the rubber type of polymer. Okay, and synthetic rubber again BNS, synthetic rubber again another category. So how we are differentiating these means depending upon the composition what we are having inside the monomer. Okay, what type of monomer we have. So based upon the monomer, this polymer is being classified, and based upon these two, the application can be defined. So if you want to do any fabric type of things, then you have to go with these two categories, Terlin and Giptal. And the bakelite, if you want to go, then it is having phenol and formaldehyde, plastic switches, mugs and buckets, all these things wherever you see. So these are being prepared with the bakelite. And PVC, wherever the tubes, sewage pipes, okay, all these things can be manufactured with these PVC. So like that, depending upon your application, okay, you can select what type of polymers we have. So these are all the different types of commercial polymers which are being available. Okay, again these polymers have been classified based upon the monomers what we have inside the material, and based upon these two, the applications have been classified. And this is about the polymers. What is a polymer? If you want to know the basics of polymers, classifications of polymers, how to define the polymers, what are the different types of polymers, and what are the structure of a polymer, applications of polymer, and uses of polymers. All these things can be studied from these references books. First one is the Introduction to Physical Metallurgy by Dr. McGraw-Hill, and the second one is Essential of Material Science and Engineering. The third one is Material Science and Metallurgy, and fourth one is Material Science and Engineering. So these are some of the references where you can find the basics of polymers. Not only the basics of polymers, what are the characteristics of each polymer and how to categorize these polymers based upon the source of availability, and based upon the structure also these polymers have been classified. And from these classifications, what are the different types of polymers which are being having, whether it is inorganic or organic. So based upon these organic and inorganic type of polymer, what is the structure which is being formed inside the polymers. So you can study those things, and from this structure and all the availability of the sources, how to classify the polymers based upon the monomer, and based upon these classification and monomer, where to apply. So all these things can be studied with these references books. Thank you for the session.
Like, share and subscribe. Hit the bell icon for more updates.